My name is Varshini. I am from SRAT College, CSC branch. Now I am going to say about the types of operators in C. Operators. It is a symbol used to represent some operations or computations. Operators are special symbols or keywords using programming languages like C++, Java, Python, C, etc. to perform specific operations on data. They take one or more operands, values, or variables and produce a result. Example a plus b. Here, plus is an operator and a and b are operands. Classification of operators. There are three types of operators: unary operator, binary operator, and ternary operator. Unary operator. These are the operators perform an operation on only one operand. Binary operators. These are the operators perform operations on only two operands. A ternary operator. These operators perform an operation on three operands. Types of operators in C: arithmetic operator, relational operator, logical operator, assignment operator, increment and decrement operators, conditional operators, bitwise operators, and special operators. Arithmetic operators. These operators are used to perform mathematical arithmetic operations like addition, subtraction, multiplication, division, modulo division. These are the binary operator, hence requires two operands to perform operations. Plus symbol indicates addition, it returns sum. 12 plus 2 is equals to 14. Minus symbol indicates subtraction, it returns difference between two operands. Example 12 minus 2 is equals to 10. Asterisk symbol gives multiplication, it returns product. 12 into 2 is equals to 24. Slash symbol indicates division, it returns quotient. 12 by 2 is equals to 6. Percent symbol indicates modulo division, it returns remainder. 12% 2 is equals to 0. Relational operators. These are the operators used to compare two operands or data items or expressions and gives relation between them. Hence, they are also called as comparison operators. These are the binary operators. The result of a relational expression is always a Boolean value, that is either 1 or true or 1 or 0, true or false. If relation is true, it returns 1. If relation is false, it returns 0. These are the symbols of the relational operators. It is greater than symbol. 12 is greater than 22, it is false, so it returns 0. 22 is greater than 21, it is true, so it returns 1. Greater than or equals to. 22 is greater than or equals to 22, it is true, so it returns 1. 22 is greater than or equals to 21, it is true, so it returns 1. Less than symbol. 21 is less than 22, it is true, so it gives 1. 22 is less than 21, it is false, so it returns 0. Less than or equals to. 21 is less than or equals to 22, it is true, so it returns 1. 21 is less than equals to 21, it is true, so it returns 1. Equals to. 21 equals to 21, it is true, so it returns 1. 21 is equals to 22, it is false, so it returns 0. Not equals to. 21 is not equals to 21, it is false, so it is true, it is false, so it returns 22 is not equals to 21, it was true, so it returns 1. 22 is not equals to 22, it is false, so it returns 0. Logical operators. These operators are used to know the logical relationship between the Boolean expression. The result of these operators is also in a Boolean value, that is either true 1 or is false 0. These operators must be applied between two Boolean values. Example and or not. Operators. Logical and. 28 is greater than 8 and 30 is less than 48, it is true, so it returns 1. Logical or. 15 is greater than 28, it is false, but 35 or 35 is less than 65, it is true, so it returns 1. Logical not. 56 equals to 56 is not, so it is false, so it returns 0. Assignment operators. These operators are used to assign or store some value, the result of an expression, to a variable. It is a binary operator, requires two operands on either side of equals to. Example: equals to, plus equals to, minus equals to, asterisk equals to, slash equals to. Example: sum is equals to 10. The values 10 is assigned to the sum. Sum is equals to 25 plus 45. The result of the expression 25 plus 45 is assigned to the sum. Sum is equals to sum plus remainder is also written as a sum plus equals to, is also written as sum plus equals to remainder. Increment and decrement operators. C supports two powerful operators called increment and decrement operators used to increase or decrease the values of its operand by 1 respectively. It denotes as plus plus and minus minus. These are unary operators. The operators plus plus adds 1 to its operand. The operator minus minus subtracts 1 from its operand. Consider an operand m. Increment of m is denoted as m plus plus. Decrement of m is denoted as m minus minus. Increment and decremented operators are in two different forms. Pre-increment or post-increment denotes as plus plus m or minus minus m plus plus. Pre-decrement or post-decrement denoted as minus minus m or m minus minus. Pre-decrement or increment or pre-decrement, increment or decrement. The values of increment or decrement the value first by 1. Later it assign it to the operand. Example: m is equals to 5, y is equals to plus plus m. The value of m is equals to 6, y is equals to 6. Post increment or post decrement. Assign the value first, later it is incremented or decremented by 1. Example: m is equals to 5, y is equals to m plus plus. The value of m is 6, and the value of y is equals to 5. Conditional operators. The ternary operator pair is known as conditional operator. It is called as ternary since it requires 3 operands to perform an operation. It is similar to its statements in C. Syntax of conditional operator is expression 1 question mark, expression 2 is to expression 3 semicolon. Here expression 1 gives boolean condition. Expression 2 statement to be executed when the condition is true. Expression 3 statement to be executed when the condition is false. Example for conditional operator: max is equals to a is greater than b question mark, a is to b semicolon. Values of a and b were compared. If a is greater than b, then max is equals to a, otherwise max is equals to b. Bitwise operator. These operators perform manipulation on bits rather than numbers. Hence, they are also called as bit manipulation operators. It's right shift 25 right shift 3, left shift 25 is left shift 3. Bitwise and 18 and 5, bitwise or 18 or 5, bitwise not 25, bitwise XOR or exclusive or 18 5. Right shift. In the bits of a given number are shifted towards right side, then it is called as right shifting, and the resultant value is called right shifted value. Example: suppose x is equals to 15 and it should be shifted towards right for one time, then it is indicated as x right shift 1. Example: if x is equals to 15, then x right shift gives 7. Shortcut to find right shift values. Formula: right shifted value is equals to n by 2s. N is a given number, s is not number of times to be shifted. Example: suppose n is equals to 15 and s is equals to 2, then right shifted value is 15 by 2 into 1, that is equals to 15 by 2, that is equals to 7. Left shift. If the bytes of a given number are shifted towards left side, then it is called as left shifting and the resultant value is called left shifted value. Example: suppose x is equals to 15 and it should be shifted towards left for one time, then it is indicated as x left shift 1. If x is equals to 15, then x left shift 1 gives 30. Shortcut to find left shifted value. Formula: left shifted value is equals to n into 2s. Here n gives number, and given n is the given number, s is the number of times to be shifted. Example, suppose n is equals to 15 and s is equals to 2. The left shifted value is 15 into 2 into 1, that is equals to 15 into 2, that is equals to 30. Bitwise AND. The operator perform AND in of corresponding bits in two binary numbers. Here when two values are 0, it returns 0. One is 0 and another one is 1, then it returns 0. First one is 1 and another one is 0, then it returns 0. If both are 1, it returns 1. Example, m is equals to 28 and n is equals to 15, it returns 12. m 28 is written in the binary form like 1100 11100. 15 is written in binary form 01111, and by adding both of this we can get 01100. The binary form this binary form indicates 12. Bitwise OR. These operators perform ORing or is of corresponding bits in two binary numbers. Bitwise OR table. Example, bitwise OR table. If both are 0, it returns 0. If one is 0 and another one is 1, it returns 1. First one is 1 and other one is 0, it returns 1. If both are 1, it returns 1. m is equals to 28 and n is equals to 15. m or n is equals to 31. 28 can be written in the binary form as 11100. 15 can be written as 01111. m or n gives 11111. It is in it is 31 binary form of it is in the form of 31 binary. Bitwise XOR. These operators perform XORing of corresponding bits in two binary numbers. Bitwise XOR table. If given two numbers are 0, then it returns 0. If one is 0 and another one is 1, it returns 1. If one is 1 and another one is 0, it returns 1. If both are 1, it returns 0. m is equals to 28 and n is equals to 15. Then m XOR n is equals to 19. 28 can be written in the binary form as 11100. 15 can be written in the binary form as 01111. m XOR n gives 10011. It returns it is in it is 9. Its binary form, its normal form of number is 19. Bitwise NOT. These operators perform negation of bits in a binary number. Bitwise NOT. If it is 0, it returns 1. If it is 1, it returns 0. Example, m is equals to 28. Then not m is equals to 3. 28 can be written in the binary form as 11100. 1 returns 0, so m is not m is equals to 00011. It is the binary form of 3. Special operators. C supports three special operators: comma operator, size, and address operators. Comma operators. This operator is used as a separate to separate variable elements, etc. It is denoted by comma, int a, comma b, comma c. Size of operator. The operator returns the size of any given data type like variable, array, pointer, structure, union at any point of time in terms of bytes. Syntax of size of operator is size of data type. Example, m is equals to size of int gives m is equals to 2. Float num comma m. M is equals to size of num, it gives m is equals to 4. Address operator. This operator returns the memory address of a given variable. Once a variable is declared, sufficient memory gets allocated to the variable. Each memory location is identified by a unique memory address. To know the address of a variable, the address operator will be used. It is denoted by an. It returns an unsigned integer value. Syntax unvariable n. Example, int num. Address of num is represented as address of num. Thank you.